Hi guys, we're going to continue talking about quadratic functions. Today we're going to talk about finding the zeros of the quadratic functions. Now this can be helpful for a lot of reasons, okay, which we'll explore more in Algebra 2, but we'll practice finding them today. So zeros are an x value that makes the function 0, or where it makes the y 0. And basically that means where the parabola crosses the x-axis, okay? So if we're looking at this parabola here, we're saying where are the zeros? So the zeros, where does it cross the x-axis? So I can see if I'm looking at my parabola here, oh, crosses the x-axis here, and then we keep going, crosses the x-axis here, keeps going, okay? So we have two zeros, so we have one here and one here. So my two zeros, those points would be -3, 0, and 1, 0. Sometimes it's listed as x equals -3, 1, not in parentheses, okay? But those are the two zeros. Now we can check our answer on this. So we're given the function right here. So we have y equals -x squared minus 2x plus 3. Okay? And what I can do is I'm going to plug in -3 and 1 for my x values and see what happens. So I'm going to have -3 squared, because notice this negative is outside of the squared part. It's not in the parentheses. Okay, so we have this negative outside here, and then we have the negative from the problem inside there. Minus 2 times -3 plus 3. Well, -3 squared is +9 times a negative would be -9. -2 times -3 becomes a +6 plus 3. Well, conveniently -9 plus 9 is 0. So that checks out. If I do the same thing with 1, I'd have -1 squared minus 2 times 1 plus 3. So we have -1 squared, which is just 1, so that's -1, minus 2 plus 3. Well, conveniently, -3 plus 3 equals 0, so that checks out. So basically, instead of having to just randomly plug in numbers for the zeros, we look specifically at the graphs. Okay? So again, the zeros are where it crosses the x-axis. Okay? So go ahead. What would be the zeros for this parabola? So if I'm looking at this, I'd have -1, 0 and -3, 0. Or we can write it like x equals -1, -3. Okay. And again, I have my function here, so I'm going to check my answers. So I'm going to have y equals x squared minus 2x minus 3. So I'm going to have -1 squared minus 2 times -1 minus 3. So -1 squared would be +1. -2 times -1 becomes a +2 minus 3. 3 minus 3 equals 0, so that checks out. And we're going to do it again here. Hopefully me not taking the whole problem with me here. With a -3, so I'm going to have -3 squared minus 2 times -3 minus 3. Please, please, please make sure those negatives are in the right spot. That's what really throws students a lot of times. So -3 squared is a +9. -3 times -2 is a +6. I'm sorry, this is supposed to be a +3, isn't it? I apologize. So I could see here that something went wrong. I wasn't going to get 0. So it's not supposed to be -3, it's supposed to be +3, which you probably all would have started yelling at me for in class, but since you're not here, so we're going to try plugging in 3 this time. So we're going to have 3 squared minus 2 times 3 minus 3, which is 9 minus 6 minus 3. Conveniently, 9 minus 9 would be 0. So now that checks out. So that's why checking your work can be very helpful. So even though you make a simple mistake here, you can easily rectify it and be like, oh, Miss Hawes, now I understand that I had it wrong. So on a test, you need to be very careful on something like that, okay? So hopefully that helped you learn from your mistakes. Now, sometimes finding the zeros isn't that easy, and you'll learn a different way to find them when you're in Algebra 2 using factoring. So that's where kind of factoring and quadratics really come into play together. Okay, moving on to the next page. We're going to find the axis of symmetry, and we talked a little bit about that in the last section of notes. The axis of symmetry is a vertical line that divides a parabola in two symmetrical halves. Symmetrical, remember, means it looks the same on both sides. Okay? Now there's two ways we can find this axis of symmetry, okay? And we're going to do that here. Now if we're just looking at a straight up graph, okay, you can kind of see the axis of symmetry. It just goes right through the vertex, right? And we can see where that is. That's at x equals 1. My line is not very good here. I apologize. But it goes right through x equals 1, right? Because that's where that is. Okay? But if you're given 2 of the zeros, you can just add the x values and divide by 2. So you're finding the average of the zeros. If you're given one x value, or 1 0, I'm sorry, you can use the x value of the single 0 to help you find it, because that just means the vertex is on the x-axis. So I know it's x equals 1 just because of the graph, but if I wasn't given the graph and I was given the 2 zeros, I would say, okay, 3 plus negative 1 divided by 2. So you're kind of finding the midpoint, okay, like what we did with Miss Hughes when she was here. 3 plus negative 1 is 2 divided by 2, which conveniently is 1. So you can find it in a multitude of ways, okay? So if I'm looking at this graph, again, same idea. We can draw the axis of symmetry here, which actually I shouldn't be drawing as a full line. It's usually drawn as a dotted line because it's not part of the graph here. Okay, so I'll draw this one as a dotted line as well. So we get used to that habit, okay? But see here how we only have 1 0, and that's because the parabola is touching right on the x-axis. So it's actually hitting on it twice as it comes down and as it comes up. But in this case, we only really see it as 1 point. So the 0 is 1 0, okay? So that means our axis of symmetry is still x equals 1, okay? And it should always be x equals, not a y equals for the axis of symmetry, okay? Now, if we don't have a graph, we don't always want to have to graph it to find the axis of symmetry, especially it might be a fraction or a weird decimal or whatever, okay? So this is how we find the axis of symmetry with a formula. So every quadratic formula is written in ax squared plus bx plus c. So let's just practice that for a moment. So if I have like 4x squared plus 2x plus 3. So a would be 4 because it's the number in front of x squared, b would be 2, and c would be 3. Okay, so we're going to practice identifying those over and over again. If I just had like x squared plus 2, so a would be 1 because that's the number in front of x squared. There is no x, so b is 0, and c would be 2 because c is always the number without any variables attached to it. Okay, so to find the axis of symmetry, we have this formula, x equals negative b over 2a. I strongly recommend committing that to memory. Now, because of this remote learning, you won't have a quiz where you won't be able to have that in front of you, but it's something helpful. Okay, so negative b over 2a, we need to remember that. So to find the axis of symmetry, I wrote this up here. We're going to practice finding the axis of symmetry for this problem. So first I want to identify what is a, b, and c. Now I know on this problem we're not using c, but it will come in handy in later things. So we're just going to practice finding it just for giggles. So again, a is always the number in front of x squared, which is 1. B is the number in front of x, which is 3. And c is always the number without any variables. And then we have x equals negative b over 2a. Now, in the formula earlier, the negative was kind of like in front of the fraction, but you can just put it with b. So I'm going to have negative 3, because b is 3, over 2 times a, which is 1. So this would be negative 3 over 2. So the axis of symmetry would be at negative 1.5 or negative 3/2. We can just leave it as a fraction unless we need to do something else with it and you want to put it as a decimal. Okay, let's see. So go ahead, why don't you try this one on your own. Remember, we have x equals negative b over 2a. So what is a, what is b, what is c? So take a second to see if you can identify those. Pause the video. So a is 2, b is 1, c is 3. Again, remember, if there's no number in front of a variable, it's assumed 1. So we're going to have x equals negative 1 over 2 times 2. Well, that would be negative 1 over 4. So we can just leave it as x equals negative 1/4. So that's my axis of symmetry, and sometimes we shorten that as AOS. Okay. So now that we can find that, we're going to practice finding the vertex. Now remember, the axis of symmetry goes through the vertex. So by finding the axis of symmetry, we found the x value of the vertex. Okay? So to find the vertex of a parabola, step 1 is find the axis of symmetry, or AOS, as we can shorten it. And then we're going to plug that x value in to find the y value of the vertex. Okay? So I'm first going to find my axis of symmetry, so I need my a and my b and my c. So a is negative 1, make sure you're taking that sign. B is negative 2. C is 0. Again, we're just kind of practicing that for future reference. So we're going to have negative b over 2a. is equal to x. So that's going to be negative 2 over 2 times negative 1. So that's a big thing. You need to remember there's a negative in the formula, and there was a negative in my problem. So that's why I wrote the negative 2 in parentheses. Okay, so please, please, please be careful with that. Negative 2 times a negative would be 2. 2 times negative 1 is negative 2. And this becomes negative 1. So the x value, or my axis of symmetry, is at negative 1. Now to find my vertex, I take this x value that I found and plug it into my equation. So I have y equals negative x squared minus 2x. I'm going to have negative 1 squared minus 2 times negative 1. Again, notice how I put this in parentheses. So negative 1 squared becomes a positive 1. Negative 2 times negative 1 becomes a plus 2. So I'm going to have y equals 1. Okay. So my vertex is not just the y value, but it's the x and y value. So it'd be negative 1, comma 1. So I've identified my axis of symmetry in order to find my vertex. Okay. Do I have one over there? Nope, we got one more problem here. So go ahead, pause this video and see if you can do that without my help. So we're finding the axis of symmetry. So we're going to identify A, B, and C. So A is 5, B is negative 10, C is 3. Again, remember our formula is negative b over 2a. So I have negative 10 over 2 times 5. Negative 10 becomes a positive 10. 2 times 5 is also 10, and 10 divided by 10 is 1. So my axis of symmetry is x equals 1. In order to find my vertex, I'm going to plug that back into my formula. So I have y equals 5x squared minus 10x plus 3. So I'm going to have 5 times 1x squared minus 10 times 1 plus 3. 1 squared is 1 times 5 is 5. 10 times 1 is 10 plus 3. 5 minus 10 is negative 5 plus 3, which is negative 2. So I have y equals negative 2. So my vertex would be the point 1, negative 2. Okay. Now what we're going to do is we're going to take the axis of symmetry and the vertex and be able